All right, so let's look at natural language processing. What natural language processing is ultimately a way to determine whether or not certain text is positive or negative. We can look at that specific text, and determine what we want to do and how we want to predict things. So in this scenario, let's actually look at data that Google can use to determine whether or not something would be positive or negative. On this side, we want to look at data on restaurants, so data that you would see on Google Maps. You'll see that it's tab delimited because when you enter in comments, tabs aren't collected, so we won't miss out on any important information. You'll also see ones and zeros next to the data, making it either positive or negative. All the data is here in two columns. Now let's look back and look down at the actual code implemented in both Python and R to compare these two. So this natural language processing can ultimately be compared in Python and R. And the first thing we're going to do is import the data set that you just looked at and the libraries that you just looked at. Now this unfortunately takes a little while and a little bit longer in R especially. You'll see that Python has already been completed. And this is primarily because of the packages that must be installed. And specifically, we're using Jupyter Notebooks in order to do this installation. So you see that R is still working through the package installation and then trying to import those necessary packages. What we'll be doing next is creating the corpus or a container for the data and then actually running the model after everything is in. So if you look, most of the packages have currently been installed. We've got a few more, and now they have been installed completely. So now we'll go to the next step and actually create the corpus that I just spoke about. You'll see minor differences in each of the two languages and how they do it. And then we'll actually create what's called a matrix variable in both languages, just a matrix ultimately, or a vector in order to actually be able to use our natural language processing model. Then we're going to split that data set into a training set and a test set in both of the two languages. And what that'll help us do is be able to actually use our model and determine whether or not something is positive or negative. You see that both of those steps, all of those steps went very quickly in both languages. And because of that, we're able to actually implement the model and use a mathematical method to create a confusion matrix, which again, you'll see goes very quickly and very few lines of code. Ultimately in R, what you'll saw there was a few less lines of code overall, and this is ultimately due to the vector-based language. Now let's actually look at the scorecard down here, comparing the two languages. You'll see that Python overall had a higher score, even though there were some parts to R that were better in the minutia base. You see that scalability and transferability was slightly higher for R, and you could actually look at the rationale on the right-hand side. Going a bit lower, you'll see that because of this higher score, we overall recommend Python as a better alternative than R. And if you wanted a more depth look into that, you could actually scroll over the rationale, or you could go up and look more at the code like I just was. Overall, you can look all over this web page to see the differences between the two. But going in depth into each one, you'll see that Python is better for the first, then Python again, then R, and then Python. Ultimately in R, it's easier because all the variables that you input, it's easier to transfer and to scale because all of the variables are vector-based. Looking again at the code, you'll see that both of them are very readable and not a significant amount of lines. However, R did ultimately have more packages to install. Going back up to the top again, what you can use natural language processing for is, of course, stock price reactions, customer management, and sentiment analysis. There are many different things you can use it for, but it's ultimately extremely useful.